Okay, this is the end. This is inverse trig functions. They're integrals, day 2. I'm going to add on a few more questions to take a look at, and these are on page 386. The other questions I'm going to ask you to look at are 15 through 25 odds. And also, now careful, some of these are not necessarily inverse trig function patterns. They could be a U substitution. Okay, and now the other ones are going to be 27 to 37, all of them, so not just the odds, but also 46 and 47. We're going to go through a few of these ones. These ones require completing the square. Some of these are U substitutions, and this is just solving a differential equation. Separate your variables, integrate both sides. So first off, let's take a look at some of the ones in here. Now, some of these answers, you might find them on last Friday's notes package instead of this one, but we're going to try and figure these out. So, first one I want to take a look at is number 19. Number 19. Hang on. What is question number 19? This one is kind of ugly. It's the integral of e to the x all over the square root of 1 minus e to the power of 2x. Now, e to the 2x is like saying e to the x squared, isn't it? Because when you do powers of powers, oh yeah. So I'm going to say that's e to the x squared, so I recognize something. Look at what I, oh, hang on, this is dx. What do I recognize here? What am I looking for? Remember that 1 over square root of 1 minus u squared? That's an arc sine pattern. Well, it's not 1. There's something else on top. But if I was to do a u substitution, 1 minus u squared, the derivative of e to the x is e to the x. That's my du. That's what I'm... So I've got that 1 over the square root of 1 minus u squared pattern. This is going to be an arc sine. How do I know it's not an arctan? It's got a square root. It's not an arc sec. Doesn't have something out front. So arc sine, that's the pattern I want to create. So I'm going to actually do this. I'm going to say u is equal to e to the x, which means du is, well, derivative of e to the x is e to the x, du. Du is, hang on, dx. See? There it is. There's my du. So this becomes the integral of du. And I've got square root of 1 minus u squared. Now I can see it. That's my arc sine pattern. So this becomes arc sine u plus c. Hang on, there's no constant up front here, right? Not for the arc sine. The other ones do, but not this one. Now, what is u? U is e to the x. Okay, let's do it. So this is arc sine e to the x plus a constant. So that's number 19. So it wasn't already there, but I can create that pattern. So sometimes you may have to do a u substitution in order to do it. So if you ever notice that you've got something on top, that could be a remnant of a u substitution. Okay, let's try one that's a little bit different. How about number 27? 27 is a good one. What is 27? This is the integral from 0 to 2. Okay. And it's dx all over the square root of x squared minus 2x plus 2. Okay, so I'll worry about this 0 to 2 later. First I'm going to figure out whatever this is, then I'll plug in 2 and I'll plug in 0. Okay, so this doesn't look like an arc sine. It could be an arctan. Remember, 1 over x squared plus u squared, that's an arctan, but I've got this x in here. That's because it's not just x squared. This was probably a trinomial. Remember completing the square? Oh, I kind of do. So if this isn't a perfect square trinomial, take this 2 and push it off to the side. 0 to 2 dx. Remember? X squared minus 2x. I'm going to put the 2 way over here. I want to make a perfect square trinomial. And the pattern is if it's a 1, it's got to be a 1x squared, and it is. Half of this number is negative 1. Negative 1 squared is positive 1. I need a plus 1 here. That makes it a perfect square. But if I add on 1, then I subtract off 1. These three become 0 to 2. This becomes dx. This becomes x minus 1 squared. And now these two become minus 1 plus 2. That's plus 1. Now I can see my arc sine, or not arc sine, this is arctan. Arctan because it doesn't have a square root. So it's u squared and a squared. That's u and that's a. Now, do I need to do the u substitution? U is equal to x minus 1. Not necessarily, because look, du is just dx. I'm not going to get an extra constant appearing out front. So I can just go straight to the pattern. Okay, well, let's do it. So if u is x minus 1 and a is 1, this is a squared, right? I get 1/8 arctan of u over a. So it's x minus 1 over 1. And that's going from 2 to 0. Okay, now I can actually plug in 2, because look, I'm going to get arctan of 2 minus 1. So I'm going to get arctan of 1 minus arctan of, plug in 0, minus 1. Oh. Well, then you say to yourself, hey, what's the arctan of 1? I know that is, remember from before? It's pi by 4. What is arctan of minus 1? Well, if you were to plug it into your calculator, doop, 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 doop. Quick, let's get out of here. Go away. Got to make sure I'm in radians. Arctan of negative 1 is going to be negative pi by 4. Oh, that's because that was where they chose to define the arctan, that piece of the wave. So it was actually on positive and negative parts. So yeah, this turns out to be negative pi by 4. So pi by 4, that makes 2 pi by 4. This makes pi by 2. So this one did turn out to be an arctan pattern, but I had to create it. So how did I know that? Doop. X squared, well, I'm looking for an arctan, and because there's no square root, and I have this extra x. This extra x is because it was once a trinomial. So I have to complete the square. Remember that completing the square is you take the b, the second number, divide it by 2, and square it. That's the number you need. So if you need to add and subtract it, go ahead. But recognize that this part's going to combine over there. So sometimes I might have to complete the square. So some of the questions in 27, 28, 29, 30, those ones, yes, you may have to complete the square. Okay, so let's do one that looks a little bit different. Number 30. 30 is a good question. Because what do I recognize with 30? 30 is just an indefinite integral. It's 2x minus 5 on top. And on the bottom, I've got x squared plus 2x plus 2. Hey, looks familiar. Oh yeah, I'm willing to bet I could probably create an arctan pattern if I complete the square here. But what about this 2x plus 5 on top? That's weird. That's different, isn't it? Usually if I've got something on top, that's a remnant of a u substitution. Think about it. What if I did a u substitution? What if I had done the entire bottom? Let's say I said u is equal to x squared plus 2x plus 2. What's du? Well, du would be 2x plus 2 dx. See? 2x plus 2 dx. This is 2x minus 5 dx. I don't have that. But you know what? I could create that. If I was to put a 2 in right there, I would create that pattern. That's what I'm going to do. It's not really completing the square, but I'm completing my pattern. Let's see. 2x. I need a plus 2. Plus 2. And then I'm going to go minus 2. And then I've got the minus 5, right? See? I just added on plus 2. And this is x squared plus 2x plus 2. This is x squared plus 2x plus 2 dx. So I kind of inserted 2 in here. Because now this fits the pattern. This is du over u. This is like 1 over u. This is a logarithm. Oh. Okay, so hang on. Look what I get. 2x plus 2 over x squared plus 2x plus 2 dx. That's a 1 over u pattern. What about over here? Minus 7. So minus 7 integral 1 over x squared plus 2x plus 2 dx. This isn't a 1 over u. See, this is part of the du. This is an arctan. Oh yeah, we just did a question similar to this. This is an x. That's a binomial in there, and there's, okay, let's try this. So I have to split this one into 2 different pieces. Okay, this one I can just do a u substitution. I'm going to say u is the bottom. X squared plus 2x plus 2. So that way du is 2x plus 2 dx. That's what he created on top. So you see, this one becomes du over u. 1 over u du. See, there's no square root or anything. That's a logarithm. So this is going to be ln of whatever u is. Ln u. Okay, what about this one? This is minus 7 integral of 1 over... Remember how we completed the square? We did that for the last one. You might also recognize, hang on, x squared plus 2x plus 1. This is plus 1 plus 1. I could break the 2 into 1 and 1 there. So I know that this is x plus 1 squared plus 1 dx. Now, do I actually need to do the u substitution here? U is this, du and dx are the same thing. I'm not going to get an extra constant. This is a, so I can just go to the pattern. 1/8, so 1 over 1, arctan of x plus 1 over 1, plus a constant. Yay, and I'm done. Not quite. This is written in u's. I need them all written in x's. Okay, fair enough. Let's see what we get. Logarithm of, what is u? This one I did the u sub only for this part. I didn't do the u sub over there. No, because it's actually a different u sub. See, this is u, this is a different u. So u is this little beastie here, which is x squared plus 2x plus 2 minus 7 arctan x plus 1 plus a constant. So remember back when you did your initial guess? Yeah, this would have been my initial guess for the antiderivative. Wow. Do I need these absolute values? Usually, you remember, we got to put those in. Now, some people might be saying, look, I know that this is actually x plus 1 squared plus 1. It's something squared plus 1. Remember? Because that's what this turns into be. So you know what? Believe it or not, you don't really need... I know it's always positive anyways, but it doesn't hurt to put them in. So quite often, the answer would not have those absolute value bars in there. Okay, so yeah, the questions I'm going to ask you to add on, please, are 15 through 25 odds. And also 27 to 37, all of them. And I will try and make sure that all of these are online. Good luck with these, and we're done chapter 5.